Hello and welcome to my 3D video on animation for the Nintendo 64. So in this video I will go over creating and or prepping your 3D actor in Blender, recording frame data, exporting actor parts, and then I'll go over the code structure for doing this and the key function that allows us to blend between our animation frames. So the animation frames will consist of various rotations to the parts of our actors, and then I'll go over how to animate this in code. So first off, before I go any further, what we'll actually be doing is we'll be blending rotation angles. So this won't make any sense at this stage, but what we'll be doing is we'll be positioning the various parts of our model. So if I'll bring over Blender a minute to try and make some sense what I'm saying here. So here's one model here. This is our actor. So I'll just reset. Bear with me a minute. I'll just reset all of his rotation angles a moment. And then I'll explain how this was actually set up. I've literally just changed an animation before starting the video. So here's our character, and then if I show you what we have here, so we have a head, body, and we have two legs and two arms. Now all of these parts, the key to look at here is this little yellow dot here in all of them. This is the center of rotation, or the origin for each of these parts. Now if you think of it as like a Lego man, when it comes to setting up your model, you kind of want to set the origin on the part you're interested in to where it will rotate with respect to the whole actor. So for example, for walking here, if you rotate this on the x-axis, you'll see his arm moves forwards and backwards there, which is kind of what we'll be wanting to do. And then what we'll be having with our animation is we would normally have, say, 2 frames which we would be working with. So we'd be transitioning from one animation frame to the next animation frame. Each frame will have different rotations for each of the actor's body parts, and we will be using a value between 0 and 1 to blend between those 2 frames. So 0, 0 would be fully the frame on the left here, and then 1 would be the frame on the right, and then 0.5 would be a blend between the 2 frames. Obviously neither of these have any rotations here. This is just to sort of try and provide an explanation before we get started. So first off, let's actually have a look at the code running in our N64 emulator here, so you can see what we will be achieving here. So I'll be presenting how I animated these two actors here. So we have a custom Mario I created using some different model parts. This one here, I'll move them around a minute. The model parts are based on the N64 Mario from, I think it's what's it called? Let's find where these are. Yeah, Mario Smash Bros. So the Mario there is from the Smash Bros. Although it's not totally from there. There are some additional bits and pieces I had to do with that, which I'll explain in a moment. And then this Goomba model, not the feet, I created those myself. This is a low poly Goomba, which was in a DSi Mario 64. And then I created like a custom texture for him from the SNES Super Mario World. So one thing to notice here is that there's a blend value going on here. So like I said, the actual walking here, there's 3 different frame setups, and then we are blending between all of them. So you can rotate them around with the D-pad, and then you can zoom them in and zoom them out. And then if you press the left and right C keys, you'll move the Goomba around as well. He'll rotate round. If you press the Op C key, the Goomba will transition between the different animations that he has. He's currently got 2. So that was him dying there, and then walking again. That's not quite right. I'll have to fix that in a moment. And then you can press the A button to transition between Mario's animations. So that's him jumping up, that's him falling, and that's him dying. Obviously, once you're in game and then moving him around, all of those different transitions will obviously make sense. So in this video, I will literally just go over how the animations work. There will be a second video which I wasn't actually going to do, but I couldn't justify putting both of those videos, both of the content together, as I think it would be too much. So we will now jump back to here, and I will go over how I sort of prepared the model here. So I'll jump into Blender here. So initially, what I'll do is I'll save and close this a moment. See if there's another one here. So if I open up the original file that I downloaded, you can see what it looks like once you download it, or download a model that you wish to use as a base for your own. As the where is it? Here we go. So the of course it's so we'll start a new file here a minute. Okay, why? Let's delete all of that. So I need to figure out what format let's have a look what format it was first. So they'll be in various different formats here. And then one thing to note here is all these bits of textures are all over the place. This is not good, and you won't be able to, I wouldn't advise having anything like this. What you will want to do is you'll want to create a unified texture, which is what I did. So if I quickly jump back to this actual project here, you'll see that I created a custom texture. So this is a custom texture that I made here for our model. It kind of encompasses parts of what's in here, so you can see like a part of it is from there. It kind of takes some of that, and then I kind of used these colors here. You see that there's some different faces here. If I open this one up, this is the Mario face from in there. I kind of took a bit of this and then tweaked it slightly, and then I wanted a high resolution model texture. So I created a 64 by 64 and then used it as a 16 color texture here. So you might have to do some work to create textures for your models, as they're not going to be in a fit state when you sort of get them from the modeler's resource. So what I'll quickly do is I'll quickly show you where I actually went. Okay, this is not bringing it up. Okay, the easiest way is type in Spriter's resource and then go to the models resource, and then I got it from Nintendo 64 and then Super Smash Bros here, and he's kind of based on this model here. And then the other so model wise, I would say you could probably have a look at stuff from the N64. I did have a look at the Mario from Super Mario 64, and I think there was too much detail in that model, so I didn't use that one. And then you can probably get away with using a load of stuff from the DS as well, which is what I did. There was I think a Super Mario 64 from there. Yeah, here we go, Super Mario 64 DS. There was some unused models. Where was it? There we go. Obviously, I didn't use that texture there because that would be absolute garbage. So my one is based on this. Obviously, I didn't use the feet, and I got rid of the those eyebrows there. So this is just to show where you can kind of get some models as bases to kind of build off of. The good bit about starting with or looking at some of these models is that you get an idea of how those games actually had their models and how they sort of achieved some of it. So where is the actual model here? Here we go, look. So that's the one we'll open, and I'll show you what that actually looks like. Doesn't look like it's imported it. Okay, maybe we'll try the other one then. Here we go. Yeah, okay, this one's loaded in fine. So this is what this version looks like. So you will have to do some work on this, and I'll explain how you can do that here. So when you import it, this is one whole model here. So what you'll need to do is you'll need to break this up into parts. So to do that, you go into edit mode, and then we want to select faces. And then what you can do is when you sort of highlight over a face, press, what is that? I think it's, no, it's not that. Once you've selected one triangle on there, press L, and then that will select linked faces. It's easier to see here. So you'll see the head or the face here. So if I click off there, I click that one triangle there, and I press L, that will select all the faces which are linked to that. And then what you'll need to do is right click and then separate by selection. And then you'll see here that if I tab out of this now and I move that, you'll see we have the face there. So you'll need to select each part, separate it, and then give it a name. So all I did was I sort of so you see we have like two parts here, so you need to kind of split this into all separate parts. So for example, we'll select the hand there, and then you'll see we've only got the hand. So if we hold down Shift, select the arm there and press L, and then we'll separate that by selection there. So we've now got that arm there. So one thing you can do, I don't recommend keeping all of these bits and pieces together. Like what I would do is take one arm, one leg, and then when you separate the other two, just to delete those. Like, so what you need to do is you will need to sort of separate your parts and then give them a meaningful name. So for example, I will say that this is the right arm. And then do that for the rest of them. And then what you'll also have to do as well, once you've separated all of your parts, I recommend that what you do then is so if we select that arm there, so what we want to do is we want to select a good point on there for the center of rotation. So this center of rotation will be where it connects with the body in this case. So when we look first off, you can see that there's the center of rotation for it is down there, which is obviously no use at all. So what we want to do is we want to zoom in on this and find a vertex. So if we go to vertex mode here, and then that one there looks a good one for the rotation, or possibly this one up here as well, that could be a good one as well. And then select that and then right click and then into snap vertices and then cursor to selected. And now you'll see that the cursor is now at that vertex there. Then press tab to get back to object mode, then right click and then set origin, and then origin to 3D cursor. Now what we've done is our arm has the rotation there now. So if we press N to bring up the transform window here, and then we rotate round on the X axis, this will show the right sort of thing we will want. So you'll need to do that for all of the other model parts here. One thing I would recommend as well is when you're once you've split all of this apart, you need to make sure you scale it down to the right size. So what I always do is if you press Shift and A and then create a cube and then size this cube to 1. And then make sure its location is at 0, 0, which is the sort of world origin in here. And then we set the scale to 1. And then what you want to do, if we hide that a minute, you want to make sure that your model, when you scale it, fits just inside that cube. So I will now go back to my original here, so you can see the finished results here. So we have the head there, the body there, the legs. So this is what it will look like once you've kind of done that. So if you select all of this here, if we show the cube again there, if I just move that there, you'll see that height wise he fits to the cube. And the reason why you want to scale everything to a uniform like size is you need to kind of have a measurement unit in your game where everything will be kind of based off of. So what I always do is I try and keep everything down to 1 here. So when you put everything into the world as tiles, everything is sized correctly. Hopefully that makes sense to you. So what I will talk about now. So first off, one thing to note is when the front view of the camera here, Mario is actually facing away. If I move him across here and then I bring in our Goomba character here, you'll see that from the front view, the Goomba character is facing towards us. And the reason why I exported Mario facing this way is because he'll be used in a third-person camera as the player. The idea is that in his default position he'll be looking away from the camera. Obviously I could have just give him an additional rotation in the game, or rather in the world, but I chose to export him like that. Just something I thought I would mention here. So let's move that back to 0. That didn't appear to do anything. Let's undo everything a moment. And then I will position the camera in front of him again. So what I'll do now is I will talk about the model parts here. So what I did for the head here is, if I hide all of these others a minute, you'll see that I joined the nose, the ears and the hat to the head. So just like you can separate model parts, you can also join them or group them, which is what I did to the head here. And then one of the other things I did as well, if I bring this up here, so one of the let's have a look is so if I show you the texture parts here, so here's our large texture here. So you see there's the nose there. And then you can see how I've sort of set up the face here. And then obviously the key bit of the hat is the center bit there. Everything else is just scaled to 0 and put to 1 pixel in here. So I will now talk about the parts here. So you'll see that they're all set up with the origins in a decent place for them to be rotated. So let's just find where I put the so I will now talk about this here, side by side this. Bring Mario back into view here. So one thing we need to do is we need to record the offset position for each of these model parts here. So one of the things I decided for the character here is the parent location will be kind of centered just below on the ground here, below the body part here. So if you imagine a dot below here at 0, 0, 0. So if I snap the cursor to the world origin, you'll see that it's directly center here. So the idea is when you move the player around, the location is in respect to this position here directly under Mario. So all of the offsets are all in relation to this here. So the head data here, so we have an X, Y and a Z location here, which basically is the offset of that dot from the origin or the position of our player. So another confusing thing, unfortunately, is, as I've said before, for some reason in Blender the Y and the Z locations are the wrong way round for everything else in 3D, and so are the Z and the Y rotations. So when you record these numbers, X is fine, but you'll need to switch the Y and the Z around. So you'll see here I have the Y offset as 0.52, whereas in Blender that's known as the Z offset. And then the Y offset, which is the Z offset here, is 0. So depending on how complex your model is, for example, you could split the hands as separate model parts, or the feet as separate model parts. You can have as many different model parts as you like, but that just makes your animation a bit more complex. For this example, I wanted to try and keep it relatively simple, but also useful at the same time. So go through each of your model parts here and then record the locations. So you see here the right arm, which is obviously this one here, minus 0.1, 0Z, and 0.47 on the Y-axis. So you do that for each of your model parts. And then that will give you the starting offsets for everything. One thing you'll also need to do as well is decide on what you want the starting position for your character to be. I've rotated all of these angles here. So at the very start, all of these have angles on X, Y, and Z of 0, and this is how they'll be positioned. So you'll need to set all of these angles up, and then press Ctrl and A, and then rotation, and then that will apply whatever the default rotations are to your character, and then put that to 0, 0, 0. So you're kind of creating a base to build off of. And then once you've done that, you can then decide what animations you want your character to have. So there are actually more than this. I believe I recorded it in a different file. So close that, and then open the next one here with the animation data here. So these are all of the animations that you've seen here. So there's the walk with the right leg forward, neutral position, which would be this default here. And then there's left leg forward. There's the jump start, jump up, fall, and die. So however many animations you create, you'll need to add rotations for each of the body parts here. So I'll show you one to start with here. So we'll go for the first animation here for the right leg forward. So we'll start with the head here. So we have 6 on the X, and then we have -7 on the Z. And then you'll see that his head is slightly rotated in the direction he's moving there. So the right arm, if I scale that there, Here we go, you can see the names here now, what I'm actually clicking on here. So here's the right arm. So that's the right leg. So that has 67 on the X axis. And then minus 10 on the Z. And 10 on the Y. So you see the foot and the leg is fully extended there. And then we'll go to the left leg there. So that has minus 67 there. And then you'll see we have 10 and minus 10. And then if we come to the arms, you'll see the right arm has minus 67. And then the left arm, for some reason there's extra rotations on there. So you'll see here we are in a decent position now with the arms positioned as we would want them. And then obviously you can tweak these as you see fit here. And then just make a note of you'll need to go through each of the body parts and then make a note of the rotations. So we will go through adding in an additional animation here so I can show you in code. So I'll reset all of these back to 0. So we will create an additional frame and then we'll call it a star jump. So what we'll do is we will have his arms like a kind of T position and his legs kind of outwards. So the y-axis is what we need to rotate here. In Blender, obviously that's the z-axis in reality, so let's try 60. So that's minus 60 on the left arm, so that should be positive 60 on the right arm. And then I think that's going to be the same there, so let's try minus 45 and 45. And then we will rotate his head back for a good measure here. Let's go 15. No, let's 25. There we go. So we've got an extra animation frame for us to export for our character here. So the head, we've got 25 on the x-axis there. Don't touch the body. And then the right arm is 60. So bear in mind that's the z-axis, like I said. And then I know that the other one will be the minus 60 there. And then the right leg is 45 on Z. and then the left leg will be -45 on Z. So I will just undo all of these on here. And then let's get back to the front view here. So when it comes to exporting all of the body parts, obviously before you go to do the exporting, it's key that you've got all of the offsets written down or just typed out in a text document like this. Because what you're going to do now is we need to export the model at 0, 0, 0. So when we export, we shouldn't have any additional rotations on here. All of the scales should be 1.0 here. And then we file, export, and then give it a name like, there we go, Mario head. And then it would be selection only. Make sure that this is set as it shows here. And then triangulate faces and keep vertex order, and then you would export that and then do the same for each body part, and then put it back to its original position, and then put everything to 0 and export it. Again, make sure there's no rotations and the scales put to 1. And then you'll have all your model parts there. I will provide you with this Blender file here with it all done, so you can use this character here to have a muck around with. And then this is our Goomba character here, so you'll see that he only has 4 parts here: head, body, and 2 feet. So you'll have to do exactly the same with any actors you want to create here. So I only created like 2 animation frames for him. Well, I'll say 2. There's the idle one here, and then there's the there's 2 walk frames, and then there's like a die-in frame. So again, you do exactly the same for your other characters here. So that's how I did those. So any parts that you get, you'll have to kind of create a texture for them. So what I'll do now is I will jump into the code. Just close down some of these windows a minute here. So what we'll do now is we will add, first off we'll add some additional animation stuff in for Mario, and then I'll show you how that can be played. So you see here, you then need to put those arrays that you sort of type out into a source file here. So what we'll do now is we'll add in the new numbers we created just. So there's the head there. So we've got the head, the body, and then the right arm. And the left arm. Make sure I put these all as floats so the compiler stays happy. It will sometimes randomly not start if you put in the wrong data types or a data type it's not happy with. Sometimes it won't sort of convert them for you, and it will just hang when you try and run the program in Aries for some reason. So we'll put this in, I'll show you the animation, and then I'll talk you through the code that does all the heavy lifting for us. Better also keep these as well, seeing as I've So we've added our animations. Now there's a few more steps that we need to sort of take. So first off, we add a new animation state. Nope, not there. I need to give it a name as well. Okay, I think that's I think we're good to go there now. I'll explain all of this in detail in a moment. The key thing to note here is all we need to do is, for our new animation, we just add in the rotations here. So each of the different frame positions, we record the starting rotations on the X, Y and Z angles. So we should be able to get the star jump one going here. So okay, I've not seen that one before. Is it drawing that? Let's just make sure I've put one in for each body part. So we've got one for the head there. We've got one for the body. And the arms. So there should be 7 animation frames. So that was saying that it was drawing while the display was not shut. Okay. I can't see anything that's standing out there. Have I put in the wrong number? It all looks good. Let's see whether it crashes again. Oh, I know why. The number I put in. Where are we? We've added a new frame in now. I'll talk you through that in a moment. I just want to see that frame working first. Okay, I've done that wrong then. Where the hell have I done there? So the frame is there, the state is there. That's 0, 1, that should be 2, 3, and 4. Oh, wait, the state jump. jump start, jump end. Looks like it's in the wrong way round there. Have I recorded that wrong? Maybe I've done it for the arms and the legs around the wrong way or something. I think it could be because the Mario character is facing the wrong way round. The arms and legs should be the opposite way round. So let's change those again there. I think I've done that. That's the problem, I think. Because our character is facing the wrong way round. I think that's what the problem is. So let's try doing that. We'll try it with the arms first. In fact, we can easily flip those here. There we go, yeah. It's just that the, if I move them around a minute, you can see we've got the position there because he's exported facing the wrong way round. The rotations are the wrong way round. So that shows that that works there. One other issue that we need to address there is the Goomba. So what we will do there, I'll quickly address that, and then I'll talk through how the animation's actually doing what it's doing, what you need to do, which is the key thing there is what you need to do there. No, that's not right. What we'll do is we'll put the now frame and the next frame to idle. So when we switch the Goomba's frames there, so if you press the C key up, we will switch the Goomba's state. So that's what it should be. There's our Goomba walking there, and then the dying animation is this one here. Not sure his feet look right. Right, so now I will explain what's actually going on, the key parts. So I've already said that we need the offsets for our models parts. It's a good idea to create a list of the mesh IDs. Explain what those are. So when you add the mesh parts, make a note of the mesh order that you add these to the display list manager, and then these part IDs, I probably should have called it a different name than this here. So basically these IDs here represent the order of all the parts in this list here. So you see we've got the head, the body, left arm, left leg, right leg. So all of the animation orders will be in this this order here. So everything is constructed with these meshes following this order here. So let's jump into the structures needed. So we have an animation part structure where we have a mesh ID, we have the offset position and the rotation now. So these offset positions will come from this array here. The rotation now will be the blended rotation between the animation frames. So we have a const vec3 pointer. This will point to the respective rotations for the body part. So each anim part will be one of these here. So it will be head, body, legs and the arms. And then we have an anim model, and this is the key sort of position, scale and rotation of your actor as a whole. So you have the position, scale and rotation in respect to the world or the level, if you like. Then we have a list of parts. So I decided to use a fixed list here using a static array of these. You could of course have a dynamic array. If you want to have more parts, you can literally just increase this here. And then what we have is we have a number which records the part count. This is what was catching me out just now when I added in, no, sorry, not the part count, the frame count. I added in more animation frames, but I didn't change the animation frame count. when the model was initialized. So we have a part count, we have an animation frame count, which is how many animations each part will have. So they all should have the same amount in these arrays here. And then we have two IDs for the animation frame now and the animation frame next. And then these allow us to blend between two keyframes here. So this would be pointing at one frame, and then the next one would be pointing at another set of 3 rotation values. And then the blend value would be the number between 0 and 1, which I was saying before, which is it kind of governs which rotation data is more represented between the two selected frames. And then I just have one texture ID for the whole actor. And then to use these, I'll show you the steps here. Where are we? So you'll see in here there are two anim models here. We have Mario and we have Goomba. And then to initialize your model, what you need to pass in is, first off, you pass in the structure, then you pass in the part count. So Mario has 6 parts. Then the animation frame count, which caught me off when I added the last one. I didn't pass that number in here. And then you pass in the array of the offsets to your model. So you'll see here that this array is passed in. And then you pass in the mesh IDs. And then what you need to do is you need to initialize each of the parts. And this is where this comes in useful now, because this is the ID of the part. So to initialize a part, you pass in your model, pass in the part ID, as in which one in your part list to set, and then you pass in the part list rotations. So for the head, I would obviously pass in this array here. So you'll see we pass in each of these arrays to each of the parts. So these few lines here set up our Mario actor. And now I will talk about what's actually happening in here. So you see all we're doing is we passed an array of floats, we convert it to a vector 3. And then we pass it to a temporary part pointer here. And then we iterate over all of the we iterate over all of our parts at the start here, and we basically set them to 0, so we haven't got anything. First off, we kind of initialize everything to 0 at the start. That's what the anim model initialize does. And you see it also passes each of the offsets to our part, and it sets the initial rotation angles to 0, and it also passes in the mesh ID as well. So these here reference these here. I believe I've explained something wrong here. It's no, not that. Here we go. This is the bit I've kind of messed up on. This here is actually an array of meshes that each of the parts actually use. Hopefully that makes sense here. This array here, this is a local one for the actor. So this one here is not to be confused with this one here. Sorry if I've done that. So let's get back to this now. So I've talked about the initialize bit here. This just connects the mesh IDs and the offsets to each of the parts. That's what the model initialize bit does. The part initialize bit, that will connect the rotations array to the part, which is what it does here. And it also sets the rotation now to the first rotation in the respective array of rotations. So for example, in the head one here, the first rotation for the head will be taken off of this list here and loaded in. So that the initialize part bit basically connects the rotation array to the pointer inside the animation part. And then once you set that up, you also need to make sure you set the texture for your model separately and the scale separately as well. And then at that point, you're almost good to go. But what you need to do first is you need to prep the animation. So what you need to pass in is a frame now and a frame next. So at the start here, the reset animation for the walk cycle, you'll see up here we have like an array of frames for the walk for Mario and Goomba. They're both the same. So all these numbers represent our frames here. So you see frame 0 for Mario is right leg forward. Frame 1 is the idle position. And then frame 2 is left leg forward, right arm back. Or sorry, right arm forward. Basically the walk cycle. This is just handling the walk cycle here. So at the start, what will happen at the start here is it will basically load in. This will be frame 0 here, and then that will be frame 1. If the frame now is set to 255. This is just something that I'll put in to initialize the code first off. and then this just resets the animation frame, as in it will transition to the next one. So to go from one frame to the next, copy the next frame to the now frame, and then take the new next frame from the whatever animation next you want to kind of like queue up, because you're obviously blending the animation from the start or the frame now to the frame end or the frame next. So you call prep first, and then what that will do is it will connect the correct frames. First off, we set the anim model's blend value to 0, ready for a new animation. We then plug in the new frame now and frame next to the animation model. And then what we do after that is we then tell the part which rotation to start with. So that preps everything there. And then to play it, you pass in an animation speed, and then you pass in your model again once you've set everything up. So the reason why we set this to 0 at the start here is we just want to take everything and set it up. We don't actually want to animate forward, if you like. Hopefully that makes sense. So what we have inside the play here is we need to get the blend value from the animation model, and then you'll also see that the animate model here has a boolean on it. All that does is that tells you whether the frame has finished animating. So you can either animate forward or backwards, as you can see here with the blend value, but it always must be in the range of 0 to 1. And then what happens is we iterate over all of the parts in your part list, and then we take a start value, a vector 3, and an end value vector 3, which comes from your frame now and your frame next. We then use the vector 3 Lerp function, and then what that does is it outputs a result of these two vector 3s blended together. And then based on the result it comes out, we then pass that to the rotation now for that part. So this prepares the rotation now of each model part, and then the anim model render function is what then draws everything. So there are some new functions added in Scene 3D, just 2. In fact, 3, sorry. So to draw one of those anim models, we need to call the draw parent model begin. We then draw child model for each of the parts, and then draw parent model end must be called at the end. and I'll explain that in a moment. So another thing that's happening inside here is we're flipping the Z position, as I've demonstrated in all of my other videos. I kind of like to keep the Z in the game world on the positive axis, but obviously when you draw things on a negative axis, because that's how OpenGL likes it. So you see at the start here, so we have a model structure in here. So we set the model's scale, texture, angles and position from the anim models, because obviously that represents the actor as a whole. And then you pass that to draw parent model begin. And then what happens in there is we first off, we bind the texture that's passed in. We then push the model view matrix onto the OpenGL stack. And then what we do is we translate our model, and then we rotate it on the parent's rotations, and then we scale it in here. But we do not pop this matrix back off, as this is the start now for all of the children that we need to draw. And you'll see here when we draw the child, we only translate and rotate. So the translate and rotate, these are the local rotations and offset positions of each model part from its parent. The scale we passed in here is obviously added to our child here, so we don't need to call scale in here. And then we can draw the child's mesh, and then we pop this model matrix off of the OpenGL stack. And then we draw the next child part. And then once we've drawn all of the children, or the parts if you like, we then need to call the parent model end, and then this will then pop off the parent's matrix. Obviously you always need to make sure you do that, otherwise you will corrupt everything drawing. And that almost wraps up everything here. What I'll quickly go over I think that's going to break anything, hopefully it doesn't. So I'll quickly go over the Lerp function here. Quickly explain that. So how it works is we first need to know what the difference is. So we subtract the stop from the start. That gives us what the difference is. We then multiply the difference by the blend value. We then add that to the start that was passed in, and then we pass that number then as the destination here. So that gives us a blend between the two vector frees here. So if you had if you think of if we come back to the animation between Goomba here, So that would be the rotation now, that would be the rotation next, possibly if we wanted to go from one frame to another. So if we passed in a blend value of 0, we're going to get this rotation back. If we pass in a value of 1, we'll get this rotation back. If we pass in 0.5, we will get a blend value between both of these. So it would be minus 2.5 for all of them. So hopefully I've explained this well here. I don't think there's anything else additional. I've gone over everything here, so yeah, I don't think there's anything additional here. There's obviously, these are the only frames here. These are the only mesh parts. I kind of wanted to keep the all of the stuff in this demo to a minimum. So the animation stuff here, this is just a basic one. You could have additional offsets in with the animation parts here. So you could have arms move slightly from their origins as the model is animating, but I didn't want to overcomplicate all of that here. So that's it for this video. In the next video, I will present Mario and Goomba in a platformer in 3D, and I will demonstrate using third-person camera and also scrolling in 3D as well, and how to collide with things, how to minimize the amount of models that you actually work with. So we can kind of see how you might apply these animations. So thanks for watching. Let me know if you've got any questions about this, and hopefully I can try and explain it to you if you've not got a good grasp on this. So thanks for watching, and I'll catch you in the next video.